Now I'm good.
The second part of the video is random forest. So what I want to know now is what did you guys understand from that video? So we'll go off of that and start from there. What are random forests? What did you understand from the whole video?
Random forests take multiple decision trees and take a majority vote from all of the trees instead of just looking at one individual tree.
Amazing. You actually watched the video. Anybody else? What is a random forest? Any volunteers? Yes.
One of the main objectives is to prevent overfitting, right?
Correct. That's actually nice. I'm happy you watched the video too. Any volunteers? Any other volunteers? Yes.
I think it is having more decision trees.
Mm-hmm.
I think it's all about averaging the results of the multiple decision trees
Correct.
and then making the decision.
Right. But how do we build a random forest?
By multiple decision trees.
Yeah, but how? How are these multiple decision trees made? As it pertains to data. There's a very important concept in the video that explains how we create,
By the votes of it.
no, how we create data sets for each decision tree. Yes,
This is the bootstrap.
absolutely. Bootstrapping is how we create data sets. Let's understand why first. Then we'll go to the code and we have enough time here. Let's just quickly run through this, okay? If this is how our data set looks, right? What did we do? We split it in 80-20 and then we create one decision tree based off of it. Okay? For decision trees. Yes? That's what we do, right? Split the data set 80-20, create the decision tree off of that. But what happens if I want to create n number of decision trees from the same data set? I want to include more randomization in my decision trees. So what do? We are going to split our data set 80-20, but what we are going to do it by pick and replace. What does that mean? For the first data set, I might pick 1, 2, 3, 7, 13, whatever, in random order. I'm going to pick 80% of the rows from this data randomly, in no particular order. And I'm going to say that it is for data set 1. Okay? Similarly, I create another data set. I'm going to pick up 80 more rows, 80% of the rows randomly, and it's now going to be in data set 2. Now, what I mean by pick and replace is you can pick the same row in n different data sets up till n. Okay? So you can have the same row in n different data sets. In bootstrapping, think of it like this. If I have 10 rows, okay, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. What bootstrapping will do is, it will create one data set. Look at the black lines, okay? 1. This might be one data set, okay? This might be one data set. When I bootstrap, this might become one more data set. Okay? This might become one more data set. What do we see? Pick up and replace, right? When we pick up a new sample of data, we don't care if it was used in an earlier sample or not. That's nothing but pick up and replace. Okay? So now that I have created 3 different data sets off of the same data, what I can do is I can create 3 different decision trees based on different data, right? And these data sets will have much more randomization than just one. That is how we introduce randomization in creation of these. Now what happens is, in decision trees, we do it off of information gain, right? There's one more step to add randomization in random forest. In creating these decision trees, what happens is, so now these rows, right? These were the row numbers, okay, that we created for randomization. But the data set looks something like this. It has 1, 2, 3, 4 columns, right? And these are the rows. While creating the data sets, what we did was, we grouped off rows. So we added a randomization in rows. But what about the columns, right? So when we create decision trees, the individual decision trees in a random forest, we include something called as column locks. What does that mean? We say that for this step of division or this step of split, I am only going to consider 3 random columns. Okay? And these now, out of these 3 random columns, I am going to pick which is the best one. What does this have? Why do we do this? Because sometimes some column has a very high information gain. Okay? And no matter how many times we split the data, what do I mean by split the data? How many times we create different bootstrapped data sets, it is still going to, the first step of all of these 3 decision trees is still going to be splitting on that one attribute which has the highest information gain. Okay? To create a more randomized or generalized information gain and to create more variety of decision trees, we do this. We create something called as a random column set. Okay, these random columns at every stage are going to give you different information gains. So what are we doing? We are forcing the decision tree to be more varied. Okay, that is the basic concept of random forest. If you want to learn more, I'm sure you want to, please go and watch the video. Again. Okay, so this is the basic concept of decision tree, and at the end it is going to take an average vote. Okay, what do these ensemble methods do? These methods prevent overfitting, give a more randomized and general solution, and are better at giving a robust solution. Okay, great, let's write code. And let's do it on Iris. Again, we have the same import libraries, right? Yes,
Should we make a new one?
yes, please. Please make a new one so that you don't get confused. I think you can copy it off of your last part, right? We're Now that you're doing this one more time, I think it becomes easier to understand, right? These files are already online, so I'll also post the solution to homework 1 today, so that you guys can see that. Homework 2, I did sort of wait for you to finish homework 2 because I wanted to see the contrast and how you feel about homework 1 and 2. I'll release homework 3 today, okay? It will be decision trees and random forest. And don't forget, also I have pulled up my proposal. I'll post it in the files as well, okay? Try to create a similar proposal and it's due on Wednesday. This is exactly what we did in decision tree, right? No change. I don't want you copy pasting because then this will get you into the habit of writing code. Are you guys doing lead code? HackerRank lead code.
Remember that.
I will take 5-10 minutes to show you that because I think there is a huge gap between coding skills and understanding, and for you to bridge those gaps with the coding skills, I think solving lead code or HackerRank is essential.
But since these are the same exact steps with the exception of importing a few more libraries, okay, we can continue, but
Yes.
preferably not.
Preferably not, because then it's more practice for you. Because I don't think you'll be writing code other than what we are doing here today and the homework. So if you come across like problems, like I can help you learn the pattern of debugging. Because I'm not saying that you'll never write code without any errors, but you need to understand how to debug it. And sometimes you just become blind to your own code. So. Are we good till here? Yes? Should I swipe below into the actual parts?
Yes.
What are we going to do? Split again, train test. But now you would be thinking, where are we doing the bootstrapping, right? Bootstrapping happens here, and I'll tell you about it. If you guys have not watched the video for random forest, please go ahead and watch that random forest video. That will help a lot of doubts, clear a lot of issues. Okay? And I go over very deeply on, about decision trees too. Next class we'll go over, I think, SVMs and clustering. Okay. I saw your feedback. Thank you so much. It's really appreciated. What I'm going to change now is, instead of having more pen and paper exercises, let's just write more code. Okay. So it's like a fancy learn and lag thing now. That works?
Yeah.
And if you have any issues like understanding concepts or anything, you can email me. We can set up some private time if you don't want to do it in class. Of course, we also have our office hours, which are 12 to 1, right here after everybody leaves. So I can wait. If anybody of you have any questions, I can wait. If not, I can go. You can set up some private time if you want. So now do you see the common steps in all of machine learning algorithms, right? Take the data, clean it, split, train the model, do the predict, get some metrics. We'll do SVMs and clustering next week. Pretty much cover everything, I think. Yes.
I hope that we can. The topic selection is somehow dependent of what we learn. So that's tricky because I'm interested, I think, in one of the classes, the topics that will be introduced in the next class.
Which is SVM.
I'm trying to make simple, define, for example, for a marketing application, the audience, and I think k-means and clustering would be.
Okay, so what we can do is I can move the date for proposal submissions. Not move, basically if you are already ready with what you want to do, you can submit between Wednesday and the next Wednesday, right? I think I won't be covering much topics like core machine learning algorithms. Are there any more algorithms that you want to learn other than clustering and SVMs? I can take a look, but I think we have mostly covered everything that an elementary level class should cover.
Now, just for the proposal, I'm just assuming you just need like our data set and
Yes.
what we're expecting to do with
Yes.
it, and, like our
Exactly.
outline on it. Okay.
Yep, I'll also post the dummy proposal. It's just basically what method, what data set, what do you want to do, what are the metrics that you have identified, just that. Okay, are we good till here?
Yes.
Till train and test split? Yes?
Yes.
Okay, so what I want to talk to you about here is look at this n estimators, right? This n estimator equals to 100. That just means that there are going to be 100 different decision trees where we are going to take an average over, okay? And the bootstrapping is also taken care of by this classifier. It's going to pick up 100 different data sets, pick up and replace data sets, where it is also going to do the columnar, yes, it is going to randomize also based off the column. That's why having 100 is a good number. As I said in the video, you have to tune it. These are called as parameters or hyperparameters. Okay, there's something called as hyperparameter tuning. I think that is what I'm going to cover in the class after the next one. So 2 weeks off. Okay. Also, yes. So bootstrapping and randomization is done by this classifier. This hyperparameter tuning is something that we'll look at 2 classes of. Okay. Are we good till here?
Yes.
Have we created the classifier, the random forest? So now what are we going to do? We are going to fit our data now, right? After this, what I want you to do is, right, in the last remaining hour while I am getting through this random forest, what I want you to do is, I want you to take a look at all of the inbuilt data sets that are in Python, like load iris, and I want you to implement a random forest and a decision tree. And then I want you to show me right here, and you can do it in groups. So instead of doing the pen paper exercises in groups, we are going to write code in groups. And that is our in class for today. Okay.
You don't need to submit something for on behalf of last week, right?
That's covered here today. Both of them, right? Because we are doing decision trees and random forest today. Also, I showed you, right? If I want to see what all parameters are in this function, what I can do is I can Google random forest classifier with the brackets, and it's going to show up a scikit-learn documentation where I can go and see what more parameters can I add here. I hope there's like 45 minutes at least left. So let's do this quickly. I wanted today's class to be more lab based though.
It is?
So I want you to do both the models on the same data set. And then I want you to compare the confusion matrix and accuracies from decision trees and decision tree and random forest for the same data set, which is not iris. I mean, we did this right now, right? I want you to find your own data set. It can be an inbuilt data set like iris, or it can be anything that you want from the internet. But just do it in groups.
For the earlier exercise, we missed a step, I think. We didn't do, did we do,
Just did the visualization.
We did the visualization.
not the visual.
Cleaning?
No, after the decision tree visualization, there was no confusion matrix.
There was.
Okay.
There was a confusion matrix.
It's here. Just before that.
It's before.
Not before the visualization, we have confusion matrix.
Oh, okay. Okay, sorry. Maybe I missed it.
No problem. You already have the files on.
No.
Okay. So now that we have the classifier, what are we going to do? We are it itself, and then it's going to make the predictions. Pretty much the same template, but the model is different, right? So now today's in class is nothing but find a data set, implement decision trees and random forests, and compare its accuracy and confusion matrix in your own words. Do it in groups. I think you three can be a group, you two can, I mean, I'm not making any groups, you can decide if you want to do it in a group or not, but whatever, just if you do it in groups, it's helpful for you. Helps improve your communication skills as well. And in real world, you will understand how it feels when there are 4 people doing the same thing. Are we done? Do you have a question?
I'm just supporting.
Mhm. We'll take 5 more minutes and then we'll do the in-class exercise, okay? So we'll have at least 2.5 more classes before the exam, because half of the class, there are 4 more classes, right? 5 more classes.
No idea. Sorry.
I need this. Yeah, 4 more classes. 4 more classes before your presentation, and the last class will be the exam.
Presentation will still be on Zoom.
Yes. Presentation is still on Zoom. Because that week is on Zoom.
Comfortable in our comfort zone.
Yes. And we have about 9 people, right? So,
There's 10 of us.
10?
Yeah, there's like 4, 6, 7, wait.
Oh,
10, yeah, there's
10.
10.
Yeah. So there's 10 of you, I think 4 hours will be enough. Even if you give like half an hour to every presentation and running the book code and everything. So I expect you guys to run code, show me the steps what you did, show me the project report, and explain why you did this. It'll take 15-20 minutes over.
That's what the proposal's for.
And your peers can ask you oral questions as well. So. Actually, you know what? I should do this. I should make all of you ask one question at least in the entire day. One question in the entire day to anybody, whatever you want. So that everybody pays attention.
Assign us, because we don't want to all of us ask the same person bunch of questions. That would be torture for them. Okay, so
Maybe just 2 questions per person. Whoever raises their hand first gets those 2 questions. So I'll also grade you guys on like engagement. That's why I'm making you ask questions. Understand, analyze, and respond. Yes.
No, she's just trying to plug her. That's,
No, no.
um,
Battery low.
Yeah.
You can plug your. This is actually very counterproductive. There is no charging here.
and we need a coffee machine.
And we need a coffee machine here. And some food also, right? And a nice little naan.
Oh, so it's hard.
At least food. Okay. 5 more minutes, guys. Are we here? Are we done till confusion matrix?
1 second. I just have one line to copy.
Then I want you guys.
Where is it?
Okay.
Oh,
Can I have this? I found the cursor moving. Thanks.
I'll also clearly tell you how many marks for what. So participation will have some points, like participation in others' presentation will have some points. Then your own presentation will have some points. The proposal has some points, and the report will have some points. It's not just okay to do your own work, but you should participate in other people's work as well. So. Confusion. So you want to sit?
No, I'm good. Thank you. That's comfortable for me.
So we have report, we have proposal.
Yes. We have proposal, we have report, we have presentation, and we have participation.
And then is
I'm just
report one
gonna do the
After
confusion.
you'll have your report, and then you'll submit it when you give the presentation.
Okay, now the proposal will be due
Because I'm not.
this
Wednesday to the next Wednesday. I'm increasing the time period so you can think more. You can like discuss if you want with me.
So can you kind of explain this confusion matrix as well? I mean,
Yes. So look at it like this, right? In classification, what do we want to know? We want to know the true and predicted, right? So what was true and what got predicted? What was false and still got predicted? What was false and still got predicted true? What was true still got predicted false? Okay? And what was true and predicted true? What was false and predicted false?
The way it's verbally said, it's confusing. I know what you mean,
Yes.
but how we can elaborate that in a sentence to analyze the data?
I'm going to show you.
Yeah. Thank you.
I'm going to show you. I just want you to finish this.
Okay.
That's why I wrote this. Once I show you what the confusion matrix actually looks like, then you'll understand what this means. I mean, we went over it, but I can't, because I'm mirroring, as soon as I change my window to that, it's going to go away. So, as soon as you're done, I will show you what the confusion matrix is from the slides. It's basically nothing but we want to find the number of what was true and what was predicted, and all the combinations of that.
I'm just running the confusion matrix.
Okay.
do we have anything in the conclusion?
No, that's just me telling you what happened. Okay, I'll stop with the mirror to show you what is confusion matrix, okay?
I'll sit in the middle. Thank you.
Found it. Okay. So do you remember logistic regression? We did this metrics. We did this when we were doing logistic regression, right? In classification, what is important? The counts of how many values were true and got identified as true, were false, were identified as false. Okay? What do I mean by that? Look at this. What are true positives, right? Correctly predicted positive instance. What does that mean? If an email was spam and our model labeled it as spam, okay? That means it is a true positive. Okay? What do I mean by a true negative? It was negative, got predicted as a negative, right? These are our ideal cases. What are our problem cases? Our problem cases is false positives. What does that mean? When we incorrectly predicted a positive instance, when it was not a spam email, right? It was your email from, say, your director, okay? But our model said it was spam and it went to spam and you never saw it. That's disturbing, right? Something went wrong there. So how many cases that happened is what false positives take care of, okay? What are now false negatives? Incorrectly predicted negative instance. So you have a scammer who is trying to get you for say maybe a Nigerian prince scam, okay? And our model does not recognize that it is a spam and it sends it into your primary email and then you get caught in it. That is a situation we want to thoroughly avoid, right? So false negatives and false positives are what we are trying to see. And of course, how bad we did, how good we did. Okay? The confusion matrix just does this. And what I did there was what I wanted to show you how the confusion matrix, this is for a binary case, right? Spam, not spam. It's easier to understand here. But what I showed you there is for a case with 3 categories. Okay? That's all. Okay.
The
Yeah.
way we describe the results
Yes.
is covered in the example.
Yes, if you look at the conclusion.
Not just displaying the results, which is very straightforward.
Yes.
Okay, it's just interpreting, like saying this is an acceptable result or not, or this is
So we
very
don't
subjective.
actually use a confusion matrix as a result.
Okay.
We always use accuracy, precision, recall, all of these which are based off of confusion matrix.
Okay.
Okay? And F1 score. We never use confusion matrix as a resultant. We always use it as an intermediary step for us to understand. We always use recall, precision, accuracy, all of these metrics to define how well it is doing. Mm-hmm.
For the in-class activity.
Okay. So your in-class for today is get into groups. Get into groups. You guys are a group? You guys are a group?
Yes.
Are you both a group? I don't know. You need to discuss and tell me. So after you guys are done, so today's
Did you find it?
Yeah,
Oh.
sewing me.
Let's use it then.
Yeah.
Did you find the library?
so what do we want to do?
What's it called?
Wrist
Sorry. Go ahead. Go outside. Too loud. Just kidding. What'd you say?
Wrist sewing. It's sewed up.
Load press. How did you find that?
Okay, can you display it? We want to have a sense of the
No, we're
data.
doing the both, right? I mean, decision tree as well as random forest.
We'll do both in one go because they share the same DNP. Okay?
the IB
that we didn't
Python
even
notebooks.
consider.
Okay, you're stressing me out.
The Python notebooks.
Okay.
Okay, let's display the
Can't
data.
we just
The,
follow
this
step by
Python
step,
notebook,
yes?
you'll pick a data set,
So,
you'll
did two of
Copy
them for,
first. You just copy the whole document. I'm sorry.
we
You
did
need
two
the
for
variables
trade
here,
and
I'm
four
sorry.
certificates.
You need to remind
it's
me
not
how
bossy,
do
you
I
just
start
talk
it?
so much.
And
So we did two different notebooks for each method.
No, no, just one.
Welcome to the Mozilla.
One notebook, okay? This is one notebook.
What should I say?
Just copy the library name. Load trash, okay? Into it.
I just want you to implement both the classifiers back to back.
Copy paste it over here too. So
I'm looking at
double
this,
click. Yeah.
So, one notebook, okay?
Again, with the iris.
We did the iris.
I just want you to
No,
compare
just
the accuracy, that's it.
The iris is
Go back.
good. The exact
Just the iris split.
five.
You can double
Here.
click. Yeah.
Can I?
Think so.
Not on here.
Did you try to double click?
Did you try to shut up?
Okay, that's fine. Keep on going. You can replace all but this one. Then what you do to labor was honestly before the smiley smart stuff.
She found a very intense data set.
Yeah.
I can leave this, right?
Yeah.
Like
See,
this.
exactly the situation. Just running.
Oh.
We need to block scientific. No, hold on.
Well, this is what happened with mine, remember?
Yes. I'll share the code. I'll show it to you.
Do you want to do it in here?
Yeah, you will do it in here. I will just open it. Why don't you open it?
Put a drip coffee with a shot of espresso?
How did you know?
Are you insane?
That's not my first. That's my third cup of coffee. Okay, so
Today.
yeah. So can you please copy this part?
There has to be a way to avoid it. No? Is that the only way?
Yeah, please. That's
Okay, well, how about you,
just
the way?
just if you start typing def, it will do an autocomplete. Right here. No, on the top. On the in the top. Def disable underscore. Here you go.
Oh, yeah, it's just that bottom part. I'll just,
No, actually, it's not the same. Can you remove the F starting this under?
how about I run it, see if it changes it?
No.
No?
Okay. Yeah. No. Just run the code again. Okay.
I can't see it.
Sorry.
Okay.
What happened? No. Go back to the F. Remove the F from
This?
yes. Remove the F.
Class.
And then remove the second line. Add those three lines.
Well, we
Yeah.
can keep that because you have that.
Okay.
We just need to add to it.
What does this do?
Why am I torturing?
I don't know, I was gonna ask you to send it to me.
Sorry. It's usually you're skilled in typing things really fast, so that is never a concern.
Oh,
Now let's see if this fixes the issue.
so you need to have like
Oh,
random
and
forest
the-
thing as well here. You just copy from previous ones.
NP is not defined.
Just
Oh, import.
Import numpy as NP.
no, I think probably there we go. Okay.
Yo.
And let's run this one. Better?
Yes, this
Why
is
you
the
feel
same one.
irritated?
What is that?
This
Why
is
does it look like that?
because these are very precise numbers.
It's
and
UC.
So what is a row? Oh, 1, 2, 3, 4, 5, 6.
We haven't seen the data set, so we see the data set the first time.
Now this is the displaying the data set.
It really just has like a
Top 5 rows of X.
number of
It's
different
fine. I don't
things.
What's
care.
your question?
I was just confused as to why the numbers
There are
look
so
like
many
that.
variables, right?
Plug 'em on.
Exactly.
The
You,
columns.
you have 569 variables.
No, those are rows. but
Rows, 30
variables.
variables.
Yeah.
Sorry. So this is 30 variables, and they were scientific. So we have some of them.
We need to have random forest thing as well here, right? Random forest.
Oh,
You need to copy that.
are we doing it in the same
From-
one or separately?
Yes, you just copy that and then paste it there.
Ensemble here.
Yes, and you need to have classification report here with the accuracy score and composite matrix. Okay.
Wait,
Classification
what, sorry?
Classification report.
Sorry, next.
You just write there classification
Like
underscore
where to
report.
copy it from?
Okay.
Make it easier.
From
Well, no,
from
I'm just,
another one. Okay. This is
I'm just trying to look at it where we put it last time.
Just that part, but this part,
Did we put it anywhere?
that part, yeah.
I don't see it.
because one has classification report written in it. I have that one.
So there's one whole line for classification report. So there you have the random forest. Did you get the
It
random
comes
forest?
with the accuracy score. Yeah, you can just write it there. Classification
The
report.
X ones.
Isn't it there?
Yeah.
So it's good?
One second. One thing is missing is the classification forest.
Classification report.
Huh?
Classification report.
Why do I not have it then?
It's not essential. We don't
Really?
need it.
Okay. Okay.
That's why we don't have it.
Okay.
Good job, guys. Okay, can we move on?
Another one. So
Okay.
what did we
So
loaded
we get
data?
that.
Okay, do you need my
First
help?
five
I'll give you
rows.
guys 15 minutes to think. Yes?
No, it's already there.
Enough. Yeah, I think. I hope. Okay.
Okay,
the
so
next part
now,
is-
Now,
so we loaded. Sorry, wait.
You can just go there and check.
Do you guys need my help?
mm,
Okay, so now we have to split.
Do you need my help? It's simple, right? You're pretty much going to do the same thing. Just have two classifiers, two objects.
You just copy.
Predict using both the classifiers, compare the accuracy.
it sounds simple when you say it. Yeah.
So you need to bring in the decision tree thing as well. So this is what I-
I'll open the submission portals.
So should we do it separately? We're doing it in the
We're
same
doing
one?
it in the
Same.
same way
Same.
because it shares the same steps to
Okay.
some extent.
So we can keep that,
Okay,
Yeah.
yes?
You bring in the decision trees, one, just like this one. Decision tree, you just
And,
copy and paste.
I'm sorry, what are you trying to say? It's the same exact steps. You just have to remove the word instead of just.
To like create
She's
the
saying
model.
this part.
This one, yeah. This, you understood?
Yeah.
You understood?
Okay, hold on, because you need to
Oh
Okay.
no,
Wait,
this should be
hold on.
up here. Yeah,
control
that
V.
fit one should be.
Are you okay?
Yeah.
Headache?
Extra.
They should be up here. Just down
Here?
the RF, yeah, you can just. And then for the fit one as well, just bring in.
Yeah, and instead of saying printing random forest, say random forest and models.
Do I need to add something here?
Yes, it's fit one, yeah. DT classifier dot fit X train Y train, yeah. X train Y train is the same. Underscore.
Copy. Really easy like that.
Yes. Now it's fine.
Okay, now we train the data for both of them.
Yeah.
Let's
Let's go over.
let's pick one model first. Okay.
Let's do this one first.
Random
I mean,
forest.
we're
Did
just
you
doing the same
train?
things we just did.
DT.
But
What'd you
Yeah,
say?
dot
Did you
fit we
train?
did. We did
We did with
fit
our-
one, yeah.
We're gonna
We-
train it
We
right
just
now.
did it.
Did we train it?
Yeah, we just did it.
You did.
do
They
it
train
in-
it for both actually.
Yeah.
Oh, okay, you're right,
Yeah.
you're right.
Now we need to do what?
Predictions.
Now predict.
We'll do predictions for both again, okay? So first copy that block.
For decision tree.
Yes. For decision.
Today's in class, I'll keep it open till tomorrow, okay? For all the students who are missing the class and also if you need more time.
So one would be this and another would be vibrate RF classifier, right?
Before you run it. No, in the same y predict. So we need to do x predict and y predict, but for the other functions.
I'm gonna do it in two separate cells.
Okay. Or for random tree.
Or you want me to do the same
Random
one?
Do it
ones.
first in two different sets and merge if you want to, because you're actually printing.
This is for
Is that what you were saying?
decision
Yes.
tree. Yeah. Random forest.
Look at it.
No.
The definition.
8 is a very like extreme one.
That's what I
It's
said.
appropriate.
That's what I said, but read her lips and what you're gonna make.
Yep, I published it.
Thank you.
I'm sitting right here if you need me.
I keep losing. Oh, okay.
You should have written like random tree, random forest and decision tree so that you wouldn't get confused between
I
files.
know.
You should have
I
removed
wrote
the
RF actually. I don't know why I'm not looking at that. I wrote RF for random forest.
Okay, now, give me a second. Prediction completed,
Why is
prediction made.
Why is it just one? I mean, the response is just one.
Because we did,
The predictions are made.
we don't have
And
this
we have
for
a
this.
decision tree and
Yeah,
random
it says
forest.
predictions made, predictions completed.
So it's twice.
Yeah, but it should come.
What?
It should have two different response notes.
It is.
Is it overriding like is random first one overriding the decision trees one? There should be a separate
Do you want me to
one.
put in two separate cells?
No, I'll make it easy. Predictions made. Predictions completed for. Just type it. For decision tree. Decision completed for random forest.
How do we know that both made the same prediction, right?
No, they won't make the same prediction, and they're.
But we have already ran
But
the
we need to
same.
and this is why we need to start splitting the y predict 1 and 2, otherwise they will override each other.
Yes, I'm saying the same
Yeah,
thing.
so what you make here is
What predict? Zero?
a underscore, for example.
Where? Here?
You just write predict zero.
No, just write
Okay.
two letters.
Okay.
One of you at a time.
Just a minute. I want you to split the data set 80-20.
Mm-hmm.
After the split,
Mhm.
replicate the splits into another variable. So y predicts and all of the variables, I want you to replicate it so that you can use a classifier on the same thing for y predict, okay? And the second classifier for y predict 2. The same test data, but predictions will be separate.
Yes,
Yeah.
that's exactly what I'm doing now. Okay, what you'll do here, underscore dt,
What are you pointing at? This one?
because
Yes.
this one is decision tree,
Or
yeah?
decision tree, yeah.
Underscore.
This is a,
Y prediction.
no, after print, okay? Underscore
Underscore
dt for, yeah,
By.
and this one,
Oh.
underscore RF. And then
Okay.
Run it?
Run it, please. And
Is it already?
done. So now we have y test for both.
Sorry, 1 second.
But it's the same.
Just
Why?
let us know.
No, you don't have to go away.
I wanna. So let me see.
Just telling my mom what to feed the dog. Okay. Yes?
Now after doing the predictions for both, what is next? We need to. Let's go first.
Did we do the test she was talking about? The 80-20?
We have already split the data set. Okay,
How do
and
you-
when we did the predictions,
Oh, we did
trained
that,
our
right?
models, we did the predictions. What we need to do now is evaluate the model.
Anything I ask, you say the opposite. It's so funny. Okay.
test as well, y test, dt and y test.
No, actually, the test is the same.
Because it will
The
be
x,
different.
the x,
No.
X has
term,
to change, right?
Predictions will be different.
predictions only will be different because predictions is an outcome of the
Oh.
you understand what I mean?
Mm-hmm. Yeah, yeah.
Oh, it's pretty accurate.
Okay.
Then we have to do this for the same one, right? Before we can do the other one?
We can do the confusion matrix, yes. Yes, please. We can add it in the same blockade, so we can print everything together. Here, yeah. Please have run it. Let's see how it looks. Just the
Oh, we
predict
need to have-
underscore predict needs to be on underscore dt. Maybe we need just a new line.
What do you mean?
We need to do for random forest now.
Does that look right?
No, because you were trying to mimic this here, but you forget the F part. Yeah,
And there should be n.
and, and for a new line. Better? A little better?
No. Is it?
Yeah.
Did it change?
Yeah.
Of course, that slash went away, but it's
Yeah. Do you
asking
wanna
about
add
the
in-
output. Maybe.
I'm just,
It
what,
changed.
what
The
is this
output
telling
changed.
us?
This is the confusion metric. Do you wanna? But the one that I shared with you in the homework looked better, neat. Do you wanna share?
In one sentence, tell me what this is saying.
Oh, you did it this way?
You wanna present it like this?
It's, no, I was just asking you what this is telling us.
This is telling you that 39 was true, okay, both of them, and true predictions, and not here, which means
Okay.
that
Do you guys need
65
me anymore?
were true. Okay. We need more time.
No, you have time till tomorrow.
Tomorrow?
Yeah.
Of course, we
Oh,
can
oh.
submit it on.
We can submit it till tomorrow, but we have to finish it
almost-
now.
Yeah, yeah.
Yeah, I mean, I'm here till today. So.
Okay, anyways, I'm moving on. Do we have to do this?
Yeah, of course.
Okay.
But first, you want to do it that way?
No,
originally?
it's fine.
So you can interpret it
I
better.
don't care.
You don't care how to
I
choose
was
this.
just asking you what it's telling me. I didn't ask you to
Okay.
show it to
Did
me.
you understand what I'm trying to say when I
All you
sent
did
it
was
to you?
point at
It's fine. The model is
Oh, you-
predict
Is it
using
true?
this law.
Wait, what I'm asking is it true positive, true negative,
It's,
false positive, and
it's
false
the same
negative?
thing, basically.
This is true positive,
True
and this
positive,
is
true
true
negative?
negative. No,
No, which one?
true negative is a 65.
True positive is 39,
True positive is 39.
39, true negative is this one, and then the false one is
Yes,
3
exactly.
Okay. Then the error isn't much then, 7, 8, 9, 10. In this much of total sample, the error is just 10. So this is good.
What I get is you eventually just get to the training option.
To be honest, we need to usually
So you want to do this?
no,
training-
not in the same
training
block
split.
if you don't mind.
I do mind.
Because, but is it done? The tree model? We want to finish the tree model.
This is the tree.
Is it? Oh, okay, then you're right.
Mm.
I'm sorry. You don't have to.
My ear is gonna burn
Okay.
off.
No, this is not iris flower. We need to
Yeah, she knows
classify.
that.
What should we write?
And this,
We don't know what we are writing. What is the
Right.
data set?
and that's why I said display the variable.
Should we
square.
display it?
Yes. We need to display the variable.
Where should
names.
I do it?
We didn't display here the variable names. Can you please display it?
I
How,
forgot
how,
how to
how
do
do
that.
we like see the data set?
No, you just have to display the.
Okay, tell me how to do
variable
it.
names.
I'll do it. Forgot. Okay, nobody knows how to do it.
Not by heart.
see that.
You can just
Oh, malignant and benign. Benign means the growth is not cancerous. Malignant means it is cancerous. Good job. Thanks. My medical school's paying off.
okay. Then what we're trying to predict is if it's malignant or benign. That answers your question. Visualization complete the traces. Yeah, of course. Sorry. No, it's not bad. Go for it.
Is that okay? Okay, I hear. Oh no, I'm okay. I thought you meant split this. I'm not there yet. Okay, so that's it for the decision tree.
Mm-hmm.
Now we can do the. Okay. So where did we leave off? We left off. Okay, we have to make a prediction. Yes.
We are predicting whether the breast cancer is benign or malignant.
I just figured
So
it
that
We
is.
figured that out.
Oh really? Okay, these are the two
I
levels.
went back and
We did it
presented the
right.
variables and
Thanks.
we should be very loud because whatever you say I will say yes and then you probably didn't hear the video. He said I have to go and I said okay.
I want to print this.
We did that. Sorry, like ignore me.
So we already
Are we
have the
done with
decision
the
We
tree.
have to just evaluate. Sorry, we have to do this.
Everyone's getting the data.
This is for the random forest. So
It's just saying if often performs better.
okay, underscore rank RT, the white predict. Yes, in the random forest. In the white predict.
Then why predict R?
underscore.
RF? Oh, yes.
Yeah, yeah.
I don't even think we assigned it. Oh,
Yes,
here's
it's
one.
90.
We did everything.
So it's a better one. The another one had 90.
Yeah.
But this is not good enough based on the subject.
This is a
Wait,
used
does it
data
have
set.
to be close to 1?
No, the accuracy has to be the accuracy has to be I think industry standard. I mean it has to be above 99%.
Accuracy?
Mm-hmm.
I don't think so. But it has to be above 99%.
Good.
Fusion matrix 39. Can I see the fusion matrix for the other one? So this is for 37, 39, 70, 39, 65. Oh, it has 65 like true negatives, and it has 70 true negatives. That means this is identifying
I'm just waiting here to see if anybody.
correctly,
No,
right?
you
5 more correctly.
You have to list down bunch of
Oh yeah, and did you get Tosh's email?
things to measure.
Text me.
So you have the F1
Tosh,
score,
did you get his
you
email?
have the accuracy,
Yes.
you
Yeah.
have the recall,
He was just-
I
you have to
Precision.
display
tell
all
him I
those
opened
Right
the.
now?
and precision.
in
Yes, I'm
classes
sorry.
and
It's okay,
Precision,
okay.
F underscore,
For
and
homework? Okay, yeah.
recall.
How do we do
in-class
that? We
assignment.
don't have an
It's
example
open till
of it.
We
tomorrow
don't
night.
have any.
Okay, perfect. I'll text him and
So we had it
Okay,
from the
Google it.
last week.
Are we sure we have to do
We
that?
had it from the last week.
I
Right?
had
But
it in that
not,
assignment.
not between pork the decision
I
tree.
can open our last week's homework.
Did you do it on your copy?
What?
Did you do it on your homework?
Yeah, I have done it.
Did you do
Oh
it?
yeah, I did.
The
This is for logistic
classifications.
regression.
Okay. Then evaluate.
We don't have to do that right now.
Because you want to compare
Because I
both of
think
them.
this is for
want-
logistic regression.
Hmm?
This is for logistic regression maybe. And we don't need it here.
You want the F1, you want the precision. Record F1 score, forget the support. You don't know what is support, okay?
I think the accuracy is what we're looking for, no? I don't think it's.
Accuracy is one.
I don't think we.
Accuracy, she
Let's
just
let's
mentioned,
just
she
ask
just went through.
whether we need to just have we have this
Here's
just
the
for
accuracy.
logistic regression.
Accuracy is covered in that function. Make it easy and run the function for both so we can have a comparative view.
So how do we combine the both right now?
We just run here, one on y, sorry, just run this function twice. Once on y predict underscore blah blah blah. And
Yeah, it's good.
So it says 40.
Yeah, that's good.
It's like this.
Why is it printing out two columns?
Hmm?
Looking at
Nadim.
y tests.
I'm trying to
Like mine.
Y test, Y print, one for DT and one for RF.
But I can take it.
Oh, it should be separate maybe.
We
It
have to
should be separate
define
in
class.
separate line.
We have to define classification.
It's
Yes,
not.
I was saying that just to have a
I don't think we need to do a classification report though.
That's it.
in after confusion matrix you can just write it there. Comma classification.
You're just printing out the row numbers.
Yeah, it's fine. I go there, I do that. But you need to do this in
the
separate
function
line.
twice. Yeah.
Okay? You need to copy all this and instead of DT write
Actually, we need to run the the classification report before we print. Is it? No, it's just we call it and we insert the parameters, right? So that
You
should,
run it? Yeah.
here we go. Okay, and one more.
And for RF. This is a tree. Your typing skill is amazing. RF.
That's your compliment to me.
Okay,
Okay,
now
can I leave now?
looking them side by side. First of all, this one is more in terms of accuracy, it's higher. In terms of precision, it's higher. I don't understand what's recall and F1 still. Okay.
Who's better? One is like
So this is exactly
so
what
zero means
no support forget about
purity. Zero,
it. Because it was not in our
zero means purity. I mean it correctly predicted, so it's greater for.
she doesn't understand that when it's too close to her face.
I'm like, hello.
It's like
So it's
talk to the
1
hand.
0, 0.10 higher for this one. So it's
Shallow.
better.
Done?
Mhm.
Yeah.
So do I just download the file? Okay. And then
No, hold on.
what?
Compare the performance.
Yo.
We just did that.
No, you want to explain, right?
Just write 2 lines at least.
Yeah, I know.
Okay. So
Maybe like this is better than that's it.
We'll keep it simple.
as per
So she can go.
our result. As per
That's the
results.
result. Random.
Oh, which one's better?
Random predictions.
Which one is 0 and which one is 1? Is 0 malignant and 1 benign? Which one is
Oh, we didn't assign.
We don't even have to think about it because this is it's one of the results. Okay, we don't have to think about it.
But benign is like, it's not risky. Benign is like anyone can have.
Yeah, it's just a growth.
Malignant
It's not
is like,
cancerous.
Yeah, but you don't have to even think about it because both of them, this results here, precision is or accuracy is higher. Precision is higher in both conditions than this one. For one, it's equal. For the second one, is higher.
yeah.
The recall is what I want to understand what's recall better before I said recall and everything.
How many of those positives we
No,
are
no, no.
actually?
No, no, no.
Actual
okay,
positive
what
cases,
percentage?
denominator
So remember
correctly
for Samir it was like R1 or something like that? It's what percentage does the model correctly identify? So what percentage does it correctly predict?
to 93%
Yeah.
for
That's the record.
that zero, level 0.
So the higher the better.
Yes.
Yeah, but like what the
But
thing
it's
is,
this-
what is 0 and what is 1?
0 and 1 is malignant and the other one is not.
It correctly
Yeah, but we need to know
predicted.
which one is which to see
Yes.
the
I'm
result.
trying to see
Okay.
which one is
Um,
0.
Do we need a classification report? Why are we doing this?
My question is, how do we know
How you wanna
like
evaluate
which
the
level is
performance?
which? I mean,
Okay, how you want to
Which-
compare with
which level is 0, which level is 1? So, how do we know that? There are two basic levels, malignant and benign. Which one is 0? I mean, which one is malignant and which
Instead
one
of
is benign?
instead of explaining that, which one easier.
So is there we can assign malignant and benign to 0 or 1. So how do we know which one is which?
Excellent. Google it.
We tried. Well, did we try?
No,
We didn't try that
we didn't.
actually.
If it's an inbuilt data set, it will have all of it.
Mm. Pinky. Pinky, pinky.
Brother hates me.
What do we
I'm also sitting right here, so if you guys are done and you want to submit and go home, that's fine. But I'm here if you want to talk about anything else.
That's our only question. Which one's 0 and 1?
No, it's like office hours. You want to talk to me about the class, you, yourself, work, life, anything.
Yeah, I will ask about the data set selection. Okay, I want to pick a new topic for the problem that I have no experience with at all, or it looks completely new. Instead,
Oh my goodness.
Kernel or k-means?
k-means, yeah. And try to use that, for example, find the data set and to make sure that I learn this, I probably implement it. But if there is a way that I can have a combination of those learnings in one data set, where I can provide a current approach to, or should I make it more complicated because I already read it?
You will be regretted. Just keep it simple.
Okay,
Divided.
0 is malignant, 1
So,
is benign.
speaking about
Oh.
the data set,
So,
I
truly
want to
predicting
start
benign
from
and truly
online
predicting
was
malignant
One
is very
second,
important.
one second.
You know?
Is that feasible?
One is benign.
No, I have to upload the data set at some point.
B and IGN.
Okay, so that is not feasible.
And
Okay,
again.
I'll,
B,
that's good,
E,
it's okay.
N, I.
Just think loudly.
So
Thank you.
you'll have to upload all of your
So-
data set, your materials, and your report.
You can
So let's just quickly run through what we know about decision trees and what we are going to do with random forests, okay? So, just an FYI, there is going to be one question in the exam where you're going to have to find the information gain and you're going to have to find the entropy for at least the first step, okay? In this, in the exam. So I want you to be prepared with that mindset. Yes? So if you don't understand something with the information gain or with entropy, now is the time to speak up. I wasn't going to tell you this, but it is going to be on the exam. So I don't want you guys to be blindsided. If you don't know something about entropy or information gain, now is the time to speak up, because you'll have to do at least the first step in the exam, right? What was the first step? Finding the best attribute to split on, right? Okay. So, before the video, we were ID 3. What did we do here? We calculated the entropy of the data set. Then we calculated the information gain for all of its attributes. Then we chose the attribute with the highest gain to split on. And then we repeated recursively for every single attribute. But what I recognized was, when I talked about these formulas here, right, a lot of you got confused with the conditional probability here, correct? A lot of you got confused with the conditional probability here. So if you go into the video and take a look at it, I've explained and added a few slides for conditional probability. Did you guys happen to take a look? Yes? Do you have any questions in conditional probability? Do you want me to go over it one more time? Yes, no.
Yeah,
You don't mind? Okay, let's go over conditional probability one more time. So, imagine, you know what, let's take a real world example instead of the formula. So, you have a dice, okay, or instead of just a dice, remember the rainy example, right? We talked about if it is raining, do we want to go out or not when we started decision trees, right? We had that example where we wanted to get an umbrella, use sunscreen, something. So what was that decision based off of? Some prior knowledge that it was raining, right? So think about conditional probabilities such that when you know event A has happened, what is the probability that event B is going to happen, right? So in mathematics, there is always a dependent and independent variable that we see, right? Here it is nothing but a dependent and independent event. When can we find conditional probability? When there is a dependent event. What if the events are not dependent, right? What if I'm trying to think of two independent events. Okay. Painting the roof green and you going out are independent events. Just because the roof is green does not mean you will not go outside or you will stay inside, right? It does not, the color of the roof does not influence your decision. So even though there are events which are in the same space, which others might think that influence your decision, do not influence your decision, right? The color of the roof does not influence your decision, but raining does influence your decision to go outside. So two events which are closely dependent on each other, those are the events where you can find conditional probabilities. When we say conditional probabilities, what do we mean? We mean that find the probability of something happening when something is given. If you look at the wording in this sentence, right? Find the probability of rolling an even number given that a number rolled is greater than 4. What does that tell us? What is the prior knowledge here? And what is the conditional probability we are trying to find? I want this answer coming from you guys. A simple line, right? What is dependent on what?
The probabilities, the set of probabilities that we're trying to define is defined. We have a range of options that might occur, and this is a subset of these.
Right, no, I'm just asking you what is event A and what is event B. If you're rolling a, yes.
Isn't event A it being an even number, and event B is it being greater than 4?
Exactly, two events, right? What are the two events? The number rolled being greater than 4. Everybody has played with a dice before, right? Everybody has at least played one board game before. Snakes and ladders at least, right? You know when you roll a dice, there are 6 faces, right? You get 6 numbers. And it is a fair die, so we cannot say that one number is going to have more probability than the other. So that's what we mean when we say a fair 6-sided die, right? Any of the 6 numbers. What is event A? Rolling an even number. What is event B? Roll number number is greater than 4. Two events, right? They are dependent on each other because the dice roll is the same. Yes? Do you see why they are dependent on each other? When you roll a dice, that's when you want to see if it is an even number on the same dice and that the number rolled is greater than 4. It is the same dice that you are rolling. So both the events are dependent on each other, right? What probability we are trying to find is conditional probability. Why? Because if we roll a number greater than 4, then and only then I want to see if what I rolled is an even number or not. Do you see what I mean when we say conditional probabilities? Find the probability of an even number conditioned on the probability that the number rolled is greater than 4. If there are no samples, given that the number greater is not, the roll is not greater than 4, we don't care about this part. What do I mean by don't care about this part? Then it doesn't hold true, right? The condition is false. So that's what we do, right? We define our events. We create a sample space. Everybody has done this in probability, right? Creating sample space. Anybody who wants to understand how to create sample space? No? I can tell you again. What is a sample space? All the possibilities of some event happening. What was our event? Rolling a dice, right? So what are the probabilities of rolling a dice? I can have a 1 when I roll a dice, 2, 3, 4, 5 and 6. Only 6 because that's the only, because it's only one dice and 6 faces, correct? With 6 numbers. So this is our universal space or sample space. In probability sometimes it's also called as a universal space. In event, what was event A? Event A was even numbers, right? Out of the sample space, this is the possibility of numbers happening, right? What are the probable numbers? In event A, we say what are the even numbers because that is our event A. 2, 4 and 6, correct? What is event B? Numbers greater than 4. So out of the sample space, how many numbers are greater than 4? 5 and 6. So we have all of the sample spaces now. Let's compute individual probabilities of an event happening. When we say individual probabilities, that means we are not worried about its dependency, right? Regardless of anything happening, what is the probability of rolling an even number? This is easy. We had 3 in our sample space, right? And what is the total number of outcomes that can happen? What is our universal space? 6. So what is the probability of rolling an even number? 50%. Because half of it is even and half of it is odd, right? So even logically thinking, you realize it is 50% chance that an even number is going to happen. What is the probability of number being greater than 4? There are only 2 favorable outcomes, which was 5 and 6. What was the total sample space? 6. So what is the probability? 1/3, right? Because 1/3 of the numbers are greater than 4. Okay, what is an intersection? Basic probability. What is an intersection? When I do this, what is an intersection?
It's common.
It's where both the variables are like equal to, or like the ones that are support both claims of your variable.
So it is nothing but a
Common element.
common elements, right? The intersection between both common elements. So how many outcomes that are both even and greater than 4?
1.
6, right? The number 6, not 6 outcomes. One outcome, but number 6, right? what will be the probability of the intersection? 1 by 6, because it has a 1 in 6 chance of happening, right? That both that it is both a even number and that both it is greater than 4. There's only 1 by 6 of a chance happening. Correct? We good till here? So now what is the conditional probability? Conditional probability of B given A is nothing but A intersection B, common items happen, probability of common items or intersection happening between both of those. That's why we need dependent events, right? What if it is independent? Then the intersection will be zero. So this divided by the probability of A happening. Why do we do this? Logically. Because A has already happened, right? So how many times did A happen, and what is the common? How many common times did both the events occur is going to tell us how many times can B occur. Okay? This is a very logical formula. I'm not going to explain this because this is a probability formula. I didn't devise this. Okay? But I'm just trying to explain it to you logically how we can come to this. This is a fixed formula in probability.
Excuse me.
Yes.
Based on the question, shouldn't it be probability of A given B?
Yeah, sure.
Yeah, because the result is not complete.
Yeah.
Yeah. Okay.
Yeah. So if that happens, then how will we substitute the number?
It will be divided by probability of B.
intersection D divided by probability of B.
Which is? What was probability of B?
1/3, I think.
So how much does this come to?
1/2. 1/2.
Which is 1/2. Right? Easy to understand?
Yeah.
Any questions? What we did here was just flip it. We wanted to see the probability of A happening given B, and this is nothing but probability of B happening given A. Right? Okay. So now, do you want me to go over the decision tree calculations one more time? These are very important to understand. They will be on the exam. The application in your code, you won't have to implement this, but I'll tell you when you'll have to implement this. When the inbuilt application of decision trees is not what you're looking for. When you want to change something in that application, that's when you need to understand how entropy and information gain work. But I don't think we'll come to that. So honestly speaking, as long as you understand the first step about how to pick the first variable, that's exactly what we are going to do for the remaining set, right? So do you want me to go over the first step one more time? Yes? Let's do this. What was the formula for entropy? Entropy is nothing but probability of an attribute happening into the log probability of that attribute happening, right? And what is I? I here, what does I do?
Variable. Number of variable.
Right. But would what entropy is for. What is entropy for? What do we understand by entropy?
Whether a class is pure or not.
The class is pure or not, right?
Yeah.
So the only attribute that we are worried about is, how will we know entropy? What is entropy? What attribute are we trying to find the entropy on? What should be pure? When we say all samples of the same should be pure, or all samples should be of the same class, what attribute are we looking at? Yes.
Well, I don't know about this. I mean, I know with the example we did before with the sunny and all that stuff.
Yeah, but this is a very simple question, right? There's only two attributes here.
Yeah.
So which attribute are we going to calculate the entropy on?
Well, like based off the ones on the left, we're going to see with ones that are similar on the left if they have the same outcome on the right.
Right. So what are we worried about? We are only worried about this label column, right?
Yeah.
No matter what becomes on the left, there can be 2 more attributes, 3 more attributes, right? We are always going to partition this label output column to find the entropy, because that is the only way we'll understand if we have all yeses or nos, right? So do we now understand what attribute are we trying to calculate entropy on? Yes? Do you have a question?
No.
Are we good? Do you understand? We always calculate entropy on the label because we want to see how the label is doing. If we have all yeses, if we have all no's, what is the percentage of yes, what is the percentage of no, right? Do you remember entropy? Entropy is a probability. Yes.
This is an example of a binary choice only, but that concept can be applicable elsewhere
Yes.
later on.
You can have a lot more attributes here, but doesn't matter how many attributes you have for entropy, right? Why? Because we are only calculating entropy on this.
Now what I mean is, this is a yes or no. This is a
Yes.
binary.
So we can have maybe also.
Okay.
As long as it is categorical, we don't care, right? But then, understanding this, now I want you to tell me what is I here. If we are only worried about this column, because it is the label, why would I be summing over I?
Yes. It's
Hi.
yes, and it will be again for no, right?
Correct. So, what do we want to see, right? We want to see the overall entropy, but how will we find the entropy without actually seeing how many yeses, how many no's, and how many maybes will be? Right? So, what are we going to do? We are going to multiply the probability of yes into the log probability of yes plus probability of no into the log probability of no plus probability of maybe into log probability of maybe. Why are we doing this? Because that is how we are going to see how the entropy looks, right? Because then, if it is all yeses, then this probability is going to be 0, right? And this is also going to be 0. If the case becomes pure, the probabilities are going to all be 0. Let's see how. Because there won't be a count. So how will you calculate probabilities if the count itself is 0? understand entropy better? Do you have still confusions about what is entropy? No? Hello. I got your email. Did you start late from home?
No, actually, I was coming from South San Jose.
Okay. So I just for you, I sent out, not just for you, but I'm going to repeat it just for you. I sent out a feedback form. Please fill it. If you, how did you find the homework? It was-
Second one?
yeah.
Actually, it took me 2 days to.
I can't hear you. You were
It
saying.
actually took me 2 days to complete the homework.
So that's less, right? You
Yeah.
had an entire week.
Yeah.
So how did you find it?
It was little tricky for me. So.
Okay. You're not on the spot. We are just gathering feedback to change homeworks here. Don't worry.
Yeah, compared to the first homework, second one was less lengthy,
Easier?
not that much easier for me.
Less questions.
Yeah, this question. This had 10, the other one had 18.
Yeah. But if you look at the 18 questions, they were all a logical flow in homework 1. What I
First
tried.
5 were the logic.
It's okay, let's see how homework 3 goes. I'll try to design it much better or much different this time. I'll be more clear. But I won't change the difficulty level. I'll just try to be more clear and build up to it. Because it is homework. Okay, and you have access to everything. That's the only reason. I want you to think. Okay. So, do you now understand what entropy does? Entropy is only going to give us information about the label based off of everything that's on the left side. Let's see how. This is what we were doing, right? We want to calculate the entropy of the full data set first. Yes? So, what? Don't look at this. Tell me, based off of this data, what attribute are we going to worry about?
Playing tennis.
Rather?
Like what hour? You said?
Sorry, it's mixed. What attribute are we going to worry about to calculate the entropy?
Sunny.
Yes.
Tennis.
Play tennis, right? What is our label? Play tennis? Then what are we worried about for entropy? Playing tennis. Entropy is always going to tell you what is the distribution of yeses and nos in your label. That's it. That is exactly what it is going to do. Nothing more, nothing less. Okay? So, if we are worried about this data set, then this is the label that we are worried about. How many types of label are there? 2. Yes and no. Binary. Right? So how many probabilities will we calculate to add for entropy?
2.
2. What is the probability of yes here? I don't know how to hide this, but
5 divided by 8.
how many yeses?
5 yeses.
5 yeses? Okay, you know what? Let's do this. Let's go throughout the room and you tell me what is a probability for whatever we are calculating at that step. Okay? Do you want to start?
Okay.
So what is the probability of yes?
So there are 5 yeses. So that means 5 divided by 8.
Correct. Right? Probability of yeses 5 by 8. Why? There are 5 yeses and 8 rows. Right? 8 possible rows. So 5 by 8 is the possibility of yes happening. What is the probability of no happening?
Numbers 3 divided by
3 divided by 8. probabilities always are going to add up to
One.
1, right? So probability of no happening is 3 divided by 8, right? Are we clear till here? Easy to understand?
Yes.
Yes? Are we clear? Clear, because you are going to have to do this for a different data set in your exam.
Yes.
Yes? What if I give you a then what will change here?
The denominator will change.
Would count all 3 events.
Now what will change?
The probability would go up to 9 to be 5 divided by 9 for yes and 3 divided by 9 for no. And then you add maybe as 1 over 9.
Perfect. So you have probability as maybe, which is equal to 1 over 9. This will become a 9. This will also become a 9. Yes.
I have a question. When it comes to the exam, I know when we did this, we did it like on paper and we did it kind of that way. Are we going to do it the same way for the exam, or are we doing it on the computer?
No.
Just on paper?
Yes.
Gotcha.
I won't ask you to code anything in the exam. I don't expect you to be at a level where you'll be coding whole decision tree or whole random forest without help. So what I'll probably have is I'll have a different way to ask you the same questions for coding, but I won't expect you to write the entire program. Mhm. That's why we have the project, right? I just want to test you on your understanding in the written exam, and the project is where you'll show me how you can write code.
So it's understanding the concepts is what you're trying to assess.
Yes, from the exam. Where to use what is what I'm trying to understand from the exam. And to be honest, with LLMs and cursors, coding is a dead art. You'll be able to pretty much write everything you want with a cursor, or pretty much you'll be able to look at Stack Overflow and write the code. But what I want you to do is I want you to do a project end to end. When I say project, I don't mean like a academic project. I mean a actual work project where you gather requirements, where you sort through the data, where you clean the data, where you run a model, then you come to a solution. Okay, that's what I'm looking for, because that is what everybody is going to be looking at when you say code and application. Okay, but if you interview as a data analyst, or if you interview as a machine learning analyst, anywhere they are going to pretty much ask you something like this. They are not going to look at how well you can code. The first round will be coding, of course, which will be lead code. The second round will be something called as design, machine learning design. This is what they ask you. Can you write, if this is the data set, okay, if they'll give you 6 or 7 lines like this, they'll tell you, they'll ask you, can you write a small function to calculate the entropy? Can you write a small function to calculate the information gain? They want to see how much you know. Because any blind person can just write 4 lines of code in scikit-learn and say you know machine learning, right? But if you don't understand this, you really don't know machine learning, because you won't be able to understand what is happening. And if you need to change something, then it all goes down the drain. Okay, where were we? We were here, right? And now, what does the entropy do? We are going to see entropy is always negative in physics. Okay? So, this negative sign is outside the summation, okay? So, don't forget, it is going to be at the end. Don't traverse it in. First, calculate whatever is inside the brackets. Do you know BODMAS?
Yeah.
Yes, BODMAS? BODMAS for arithmetic, brackets first.
Yeah.
That's the order. It's called bond mass. Okay. So what was the entropy formula? Probability of x into log probability of x, right? So here what is this?
Probability of yes times log probability of x.
Yes,
Yes. And
correct. Here probability of x is 5 by 8 and the log probability is also 5 by 8, and here we are adding the log probability of no. That's how we are going to calculate the entropy. Why? If there are no no's in the data set, what will be this probability? This probability will be 0. That's how we know that the data set is pure. If this is not 0, then there still will be some value, right? And that's how we know we have to keep going. Split. The closer the entropy to 1, the worse it is for us, because it means that it is an even split. Then it is like the coin toss. The closer it is to 0, the better for us. Now this arithmetic calculation is fine because you are going to do it on a calculator anyways. I'm not worried about you doing an arithmetic calculation. But do it right, okay?
Calculator?
Calculator, whatever you want.
Okay. No, we don't have calculators. Just
Whatever you want. Google. I have a habit of using the Casio calculators.
so did I.
Whatever you want. As long as it comes to the right solution. You use log tables if you want. Okay? I can't help you with the arithmetic calculations because that is a totally different class. Okay. Do you understand entropy now? The first step? Let's take a look at information gain. Why are we using information? No. You know what? I should just start like removing things now. Stop looking at the code. Why do we use information? Logically, yes.
We want to see what feature is the best to split on.
What feature to best split on, right? Here we have two possibilities, outlook and mint. We don't know what to split on because we can't see the future, right? If I split on outlook, will I get a better result? If I split on mint, will I get a better result? But information gain is that small peek into the future. That's how we are going to understand which one to pick. Okay? Why do I say it is a small peek into the future? Because what information gain does is, it basically calculates the entropy for that attributes splits. Okay? That attributes splits and tells us, if I split on that, what will be my final information gain, or what will my play tennis look like if I split it on that. How? Information gain, if I am calculating information gain for outlook now, okay? How many possibilities does outlook have? We want to split our data set, right? So when we want to split our data set, we always split on the given attributes, right? The categorical labels. Let's not say attributes. Let's call a column an attribute and the horizontal possibilities or categorical labels as labels, and this as the outcome. Okay, so it is clear in your mind what I'm referring to. So when you want to calculate an information gain for an attribute, we look at all of its labels, calculate the individual entropy for all of those labels, and then subtract it from our total entropy. By subtracting it from our total entropy is over the entire data set, right? When we split it, we expect the entropy to go down because that's the whole point of splitting it, right? We want the data end outcome to be more pure. So that's why we subtract it and see if the value is more than what information gain for this attribute is, then we want to split all that, because that is the most gain we are going to get from splitting on the labels for that attribute. So what do I mean by that? If I split on Outlook, there are going to be 3 possible splits, right? One on sunny, one on overcast, and one on rain. Your data is going to horizontally separate, right? On Outlook, but in 3 ways, because it has 3 labels, right? So now I want to understand, if I split on Outlook and our data set gets split in 3 ways, how will our final label look like? Right? Because then the labels will get separated, right? Some of the yes will go to one side, some of the no's will go to one side. How does our end result look like? And if we want to see how our end result is going to look like, what do? Find the entropy, right? The whole point of entropy is finding how much yeses and no's are in the final label, right? Are we on the same page here?
Yes.
Okay. So if I want to look at how many yeses and no's are in the final label, once after I split, what am I going to do? I'm going to pretend that I already split on Outlook, and I'm going to find the entropy of sunny, because that is how the data set is going to partition now, right? So what is the entropy of sunny now?
0.98.
When I say entropy of sunny, we are only going to now look at the rows which have sunny, right? So in rows which are sunny, because that is your data set now. Remember, you have already split the data set, we have reordered our data set, and we are only worried about the entropy of sunny now, because it is after split. That's why I call information a glimpse into the future, right? It is a trial. We try our clothes in malls, right, before we actually buy them. That's what we are doing. We are doing a trial to see if it works, if it fits us or not. So we take a look at these three, and now tell me, how will I calculate the entropy? If that is your data set, if the underlined rows are your only data set that you're worried about, how will you calculate the entropy? How did we calculate the entropy for the entire data set? We looked at the final label. We saw how many yeses and no's were there. We multiplied the probability of yeses into log probability of yes, plus log probability of no into log probability of no, right? That's all. So you are going to calculate the entropy again, but this time the data set is reduced. Yes?
Yes.
Do you get it now? Much easier to understand because we entered it in a loop. Yes? So we calculated the entropy. This is nothing but, and when I say entropy of sunny, I mean that I've split the data set and I'm only considering sunny rows as my data set. Okay? So when I'm considering overcast, what will be my entropy of overcast?
It has 2 yes, so it will be 0.
Huh?
It has 2 yes only, so it will be 0.
Yes only, right? So I will get probability of this will only be some value. This will be 0, right? There are no no's, right? And this also will be 0 because that is how it is decided. I'm not going to calculate it. It is 0.
We'll take your word.
Huh?
We'll take your word for it.
Okay. Thank you. Okay, it is pure, right? We can see it is pure. But mathematically, it also sees that it is pure by using that formula. Now, what happens when it is raining? Hey, change color.
Yes, yes, and no.
1, 2, 3.
2 yes and 1 no.
2 yes and 1 no.
This is my data set for raining now, right? So, 2 yes, 1 no, right? Again, we calculate the entropy, right? Now that we have all three entropies, what to do now? Then we look information gain now look like? We now have 3 entropies, right? Because the attribute has 3 values. Correct?
Yes.
3 values: sunny, overcast and rain, whatever. What was the third one? Sunny, overcast and rainy, right? 3 values for that attribute. So how are we going to calculate the information gain? How are we going to read this information gain? Information gain of label and that attribute equals entropy of that attribute, entropy, the total entropy, H. This is what is entropy, right? So HY is nothing but the entropy. Total entropy of the data set minus summing up all of the entropies now for those 3 values that we calculated, right? Here attribute A is equal to sunny, attribute A is equal to rainy, attribute A is equal to overcast. We calculated this entropy, right?
Yeah.
This part is what we calculated right now. This part is what we calculated. Entropy of the label given, attribute is sunny. Entropy of the label given, attribute is
Overcast.
overcast. Entropy of label given, entropy is
rain.
rain. Right? Those are the 3 entropies we calculated. Clear? So this piece we have. Now we'll have to find the probability of that in the individual item happening. What does that mean? Probability of rainy, probability of overcast, and probability of, what was the third one? Sunny. Right? And then we are going to multiply and sum it up. Okay? This is nothing but called as information. And what is information gain? Subtracting the information from entropy is the information gain. Okay? Now this metric is what we are going to use to calculate another information gain for wind, and whosever's information gain is the largest, that is the attribute that we are going to split our data set on, right? So all of this calculation is nothing but looking into the future to see how our entropy is going to look if we separate our data set on that attribute. Okay? Let's now go to the calculation and see. So what is the information for outlook? Probability of, what is this?
Probability of sunny.
Probability of sunny, right? We are trying to find, this is nothing but the probability of V, and this is nothing but the entropy of A given, attribute is, probability of label given, attribute is now sun. Yes? That's the piece from that formula that we are calculating here. We are calculating the information, right? This is information. What is information gain? It is nothing but the overall entropy minus information. Do you see it in steps now? Yes? So we are going to sum overall, right? Because that is what we are, the formula says. What is this? This is for sunny, this is for overcast, and this is for rain. We have now information on how to split. And that gain is nothing but total entropy minus that, right? It puts us closer to 0, right? We reduced our ambiguity in our label. It is closer to 0. We are going on the right track. Do we get this? Now, all of you are going to explain to me how we did it for wind. Raise your hands and tell me very quickly how we did it for wind. You want to try?
Sure. Same thing that we did for Outlook, it's just now we only have 2, so it's weak and strong.
options are there? How many attributes is equal to weak can we make out? 2. Weak and strong, right? So we are going to find the entropy of weak, we are going to find the entropy of strong, and then we are going to find the information. Information is nothing but probability of wind is equal to weak into entropy of wind is equal to weak plus probability of wind is equal to strong into probability entropy of wind is equal to strong, right? And the information gain is total overall information, total overall entropy minus information of wind, which is this. So which number is greater? Which information gain is greater? Wind's information gain
Outlook is greater.
or Outlook's information gain?
Outlooks is greater.
Whichever is closer to 0.
No, greater. What is greater? 0.2 is greater or 0.1 is
Greater.
greater?
The entropy is whatever closer to 0.
Yes.
Sorry.
We are looking at information gain.
Information gain, whatever is more, it helps us decide better if this feature is
Best.
Splitting or
Percent.
not?
Yeah.
Yes.
We should split an outlook.
So which information gain is greater? Outlook or wind? Greater in value, greater than, less than, equal to.
Yes, it's for outlook.
Somebody from the back of the room. Outlook is greater? Yes? Right? So we'll split on outlook, right? And our tree looks like this. First step of our tree looks like this. I expect all of you to at least be able to do this. Okay? I expect all of you to at least be able to do this. I'm not worried about recursing over it. I want you to understand how it splits.
one step is sufficient to demonstrate the concept, right? Okay.
Clear?
Yes.
Let's write code. Okay. Do we have our Colabs open? Please don't download the file directly and start copy pasting off of it. Try to do it in class before you attempt it. Okay? Okay, so now I simplified the decision tree code a bit. So for me this is simplified. That's what I have written. Okay? Do you want to start? Yes? I don't hear my keypads.
Yes.
Okay. Okay, let's start by importing everything here. Okay? This notebook provides a very simple introduction to using decision trees for classification using Python and scikit-learn. We will use the classic iris dataset. Okay? I'm not going to use any external datasets. There are a lot of inbuilt datasets in Python. This one is called as iris. It's a flower. But there are a lot many more datasets called as, one is diabetes also. So diabetes, and I think there's one in that Outlook Rain also, which are inbuilt. Okay? So here what are we going to do is we are going to import all of our necessary libraries. We are going to import pandas because that is how we are going to create data frames. Why do we need data frames? When we import our data from a CSV to make it easier to manipulate, do you want me to increase the size of it?
It will be helpful for the recording too.
Better?
Yes.
Can you see? Yes?
Yeah, much better. Thank you.
So sklearn.datasets is what is going to, so sklearn.datasets is the library which has a inbuilt dataset called as iris. Okay? There are a lot many more datasets you can go, if you want to use them in projects, do that, but those are very small, so it won't help. But for you to check if your code is running well, this is a baseline. selection, we are going to do the train test split. You all know the train test split, right? We are going to train on 80% of the data and test on 20%. This is the inbuilt function to do that. Sklearn.tree is going to give us the decision tree classifier, the model train, and the plot tree. Okay, because we need to see how the tree looks too. Metrics are going to give us accuracy. Oh, one more thing. I saw that you guys did not read the question well. Some of you calculated mean square error instead of mean absolute error in your homework one. There is a difference, okay? Be sure to read what you are calculating. If you calculate mean absolute error when I am asking you mean square error, it is wrong. Do you remember what was the mean square error, what was the mean absolute error? We'll go over the metrics once more, okay? I worry that you might confuse things. I'll show you very quickly what is the mean square error, mean absolute error, okay? Be sure to read the question properly. I've given you points because you calculated some error, but please calculate the right one. Yeah. Yes?
I think I did both. Not sure. That's typical approach is to list all
Okay.
them. No.
So, I also heard from a little bird that you guys have some trouble Googling things. If you want, I can show you how to go about it, how to find the right patch of code or right example that you want to look at. So, if you want to do that, you can hit me up in the lab, or I don't mean lab, like office hours. We can go over your process together, whoever it is. I don't know who it is, but what we can do is we can go over your Googling process together, because half of your time in real world is going to be spent Googling. Nobody knows so much. Everybody knows so much only, right? I can show you where to find the right places to look at things, look at the right examples. Medium is a good source. Stack Overflow is an excellent source. I removed Seaborn. I don't want you to see Seaborn right now. It becomes a little bit messy. So don't write this, okay? This is just me trying it out.
A bit down. We have finished.
No. We are going to go over them one by one. I don't want you just copying off the board. Okay. Are we good till here? Do we know what the imports are doing? What all of the imports are doing? Do you have any questions? Do you see some word which you don't recognize? Anything from the import that you feel you don't know? Why are we importing that? Huh? Yeah, that's an inbuilt data set. That's an inbuilt data set in Python. It's used like a baseline.
Just like Seaborn.
No. Seaborn is a library. Iris dataset is a dataset, like the Outlook, Wind, whatever. It is the data. I do not want to import something from Kaggle. I wanted to keep it as easy and clean as possible. I tried to do it in then you will be able to use it in the homeworks as well, right? I always ask you to load the data set and show first 5 rows or first 5 features, right? Okay, so on the board here, what are we going to do? We are going to create an object of the method load iris. Okay, this is an inbuilt method load iris that we just imported. Yes?
Yes.
Okay.
Okay. So now what this function does is it just pulls all of the data from its storage and puts it in iris. Okay, that's all that function is going to do. Y is going to be our data, x is going to be our iris data and y is going to be our iris.target. It comes up as a pair, x and y, tuple, okay, comes back as a tuple. So when we do this iris.data, we can access the data part, and when we do iris.target, we are able to access the labels, okay, target labels. In feature names, we can have feature names by doing dot feature names. In target names, we can have dot target names by doing that. Okay, it's going to display out print iris data set, features, target, display first 5 rows, display first 5 target labels, display names, all of it. Let's see how it looks. This is how it looks. What does this mean? The features and target, X shape, Y shape,
150
first 5 rows, first 5 target labels.
number of rows and
Yes.
Do you mind going back up to just so we can see the rest of it?
No, this is just the output.
Oh yeah, no, I know. I mean, just to like look at what we need to put down. Yeah, got it.
No, we are not writing it.
Oh, we're not going
No,
through it.
we are just looking at what the output is. So, this is how it looks, right? What does this mean? What does it mean to have features in X shape as 150,4?
there are 150 rows and 4 columns in the data set.
Right? 150 rows and 4 columns in the data set. What does this mean? There are 150 rows because it is a target label, it is going to have only 1 column.
Yeah.
So does this match? Matches, right? The first 5 rows of features is this. It is just going displaying the top 5 and top 5 labels as well, just to see if it matches correctly with whatever we imported. Okay? Easy enough to understand? Questions here? No? Then we can go to the code and start writing. Right? Try to do it without looking at it much. Try to think about it logically, like how I explained. Load the features, load the target set, display the first 5 rows, display the target 5 rows in your mind. Okay? But this is how we do it. I have not used this now, but you can use it if you want to display it. The files are already loaded, so in case you run out of time here, you still have everything you need. But don't try to download that and copy of that in class, because that beats the purpose of doing it in class. This is like a small lab. Okay. In Python, when we do this, what does it mean?
Just first 5. Yeah.
Right.
What? Which thing? Okay.
This is called as list splicing. What is it called? Python list splicing. What I want you to do is I want you to go and read on it. This is how we list splice in Python.
Why didn't we use pandas?
Huh?
Why we didn't use pandas to have the x and y? We don't use pandas.
We can. It's just I try to simplify. I mean, doing just a list splice is much easier, right?
It's native, I think.
Yes.
Panda is neat.
This is list splicing. I wanted you guys to get comfortable with list splicing, okay? I know this is not a Python course, but I'm just trying to include as many of fundamental concepts as possible.
What does that do, the splicing?
List splicing, so think of it like this, okay? This is a list in Python, right? They are in their own individual boxes. The method for accessing some part to some part is what happens in Python, and it's called as list splicing. What this does is it goes from end of the list to the fifth element. So we are doing this here. We may have more, right? But it is called as splicing of a list, and that's why Python makes it faster. But it is fundamental, and you guys should understand how splicing works and splitting also. Are we good? Do we understand what is on the board here? Any questions? In the exam, what I might ask you to do is show me the first 5 rows. That's it. Or show me which features you would use as a label. I won't ask you to write the entire code, right? It's not a lab, or it's not a practical exam. Prepare well for your written exam, because it's going to include a lot of applications of whatever we have learned. I know a lot of teachers record their Zoom, but most of our work is on the board, so it's hard for me to record it via Zoom. Yes. What is there?
Oh, it says invalid syntax.
Huh?
Invalid syntax.
For which line?
Line 16.
Which line here?
25.
This one?
Print Y, he said.
That's why I asked you which line, what. So this is the normal process of debugging, right? Go to that line, look at what's missing, match it to this. You'll find most of your syntax errors.
Now I got a bigger.
What is the error?
Feature names.
Everybody understand the lab till here? Easy? What's wrong, Jatin? You're Jatin, right? What's wrong?
Data set load loaded and feature X shape is 150, 4, but then it doesn't show us why is not defined.
Did you do iris.target? Are you sure you did iris.target? Okay. So in target, did you do y dot shape? Is your y small?
We put in the right part if we had like uploaded a data set, right? So with this one, how do we see that?
Comma is not going to give you the shape of that feature. When you do something, say dot shape or dot function, it goes and defines the shape for that attribute. Okay? Did it fix? What does it say now?
Saying name y is not defined.
Are you using a capital Y here? Are you using a capital Y here? Did it fix? Do you understand how to debug now? Yes, but do you understand the process of debugging?
Yes.
If I come and tell you, then it beats the purpose. That's why I'm trying to guide you from here.
Finally different, that's why.
Are you good? Yes? Everybody good till here? Let's split the data set. Pretty easy. We've done this a lot of times. Let's just split the data set. I even added like a little elementary comments for you guys to understand. Once we split our data set, what are we going to do? We are going to create an instance of the classifier, right? The decision tree classifier. That's nothing but DT classifier. I am creating just an instance of that class. Do we understand the code? Do we understand the code? Yes? Radha, Jitesh. Jitesh, right? Jatin. Do you understand the code? If your code runs till here, please raise your hand so that I understand where are we at. Radha, do you need help? You good?
So this is for
We good?
so we put
What is it? Tell me verbally.
It says name error with all the 5, 6, 7, 8, 9 lines.
In all of these lines, did you check the capitalizations for these and then carry your capitalizations here? Why is not different? Yeah. In using capital Y here, if you are now variable goes in capital Y, your value is in capital Y. So how are you using small y? Python is case sensitive. In Python, if you assign a variable y, imagine this as a box, imagine this as a box. If you say y is equal to ABC string, then this is going to have ABC. If you say y is equal to BCW, then this is going to have BCW. Y in Python is not equal to y. Are we good? Did it fix it? Are we all good till here? Is your code running? Everybody?
yes.
What is wrong?
I just got only single values.
What do you mean single values? It should look something like this. Yes? What does this mean now? You only tell me.
It has 120 rows and 4 columns.
What has 120 rows? X.
Extreme.
And
White train has, sorry,
you're right.
and the white train has 30. But both has 4 columns. Both the shape.
Y train has?
30 rows.
Okay.
Extreme has 120 and both of them.
Read carefully. X test has 30 rows. Y train has 120 rows. I think you guys don't understand the split of data set. is all of our attributes, right? Sunny, rainy, whatever. The attributes of the outlook and windy, right? And what is y? Y is nothing but our label, yes or no. Okay? This is how the data set looks like. When we do the split, what Xtrain is doing is nothing but randomly it is going to pick out 120 rows.
120 or 150, which is 80%.
Correct. And it is going to pick out 30 rows for the test. Do you see what this is now? Xtrain is nothing but 120 rows and 4 columns. Xtest is nothing but 30 rows and 4 columns. Ytrain is 120 rows because it is only one column, which is the label. And Ytest is nothing but 30 rows. Clear?
Yes.
Are we good now? Do you understand the train split? Now let's train the model. What do we use for training? Dot fit, right? Training any model, we use the dot fit function. Classifier dot fit. When we say dot fit, what happens? Gradient descent. How did you find the guest lecture on gradient descent? Did you find it useful? Did you understand what was happening? Okay, then train the model. When it does dot fit, it calculates the information gain, entropy, or everything that we did internally. Picks the best one, splits again, picks the best one, splits again, picks the best one, splits again, until it reaches entropy 0. And all of those steps are then saved here in DT classifier. If you send me the prior recording as well, what I can do is I can upload it on Canvas in the right week module so that you can go ahead and view it. I can upload today's class as well. So you'll have a lot of things recorded. We are only training the model, okay? Once you guys have done the training, let me know. This is exactly how I ask questions, right? For the homework. That's how I've tried to do the in class too. Are we good with model training? So now let's make predictions. Now that we have our classifier, it's fit on our data. What are we going to do? We are going to put in the test set and check how well we are doing, right? What does this do? Y predicted is now going to give us 30 samples, right? Because we have 30 samples in our test, right? Y predict is also going to give us 30 samples of its predictions based off of this classifier, right? So what does this do? Y predict is equal to classifier.predict on this test data. Easy? Let's do this. You don't have to print the 5 predictions and labels. I just did this so you understand the structure of our data set.
Actually, it's pretty useful. It's pretty useful, so we can have sense of the data. Thank you.
Also added this wall part. We'll come to it, but it is useful in understanding the confusion matrix. Are we good? Did we predict? Did we predict?
Yes.
Nothing did we predict? Remember, okay, capitalizations and lower cases are different in Python. Might not be different in SQL, but it's very different in Python.
Sometimes. Even in SQL.
Based off of our predicted values, now we are going to compare the test values that we have and the predicted values, right? What is this? This is the labels of that 30 tests that are actually in the data set, and this is what we predicted, right? So accuracy is now going to be test minus predicted, and that is going to be automatically calculated by this accuracy score function. This is how it looks.
Okay. Can you just go a little bit up? I didn't get
Yep.
the code.
So you can see here the predictions and the actual labels. They are pretty close. I was really happy with how you guys did in the first homework actually. Yes.
It says invalid was printable characters.
Which one? On which line?
Like it said,
Which line here?
What did you get?
the last one.
This one
It's what F?
or this one? Or this one?
Print first 5 actual labels.
seems alright.
It looks identical, right?
Yeah, it looks identical.
Do you like this?
I think you have it.
Yeah, it's just tissue. No.
Oh, maybe here, can you see? Is there any difference?
The first side rooms.
Are we good? Do you need my help?
I just had a question.
Yes.
Yeah, so when you did your answer for the confusion matrix,
Everything seems alright.
Everything seems.
but
Mm.
yeah, okay.
Can you run this one?
Model accuracy. What is the model accuracy for you?
0.923. Step for confusing metrics.
RCX.
When you're saying like on Google. No, it's, I mean, I crashed. But I was just wondering, so are we saying,
How to read this?
yes, that's in, these are the
Did I
actual
split the
systems.
data differently?
So look at this, right?
Yeah,
I'm
I just
just
copied
asking.
these things.
Did I split it differently?
No, no. What I'm saying is this is exactly what this confusion matrix is. I've written it
And I
out.
trained it
So how
extreme.
many 2s and 2s are there? There
Did
were
you
10.
do stratify?
How many were predicted as very color? Where is the color? How many were predicted as
State and stratify equal
How many were
y? You
No.
didn't do that.
So you
Maybe
get
that's
this
why.
confusion
That's
matrix.
Yeah.
exactly
Okay.
right.
This is how you read.
I get to it. Stratify.
Is that with every
equal
kind
y.
of confusion matrix, it's gonna be like diagonal,
Why?
like if we
Not
did a
one.
fourth one, let's just say,
Yes.
and we had it predicted whatever here, would that mean, you know, you said true, or like,
Yes.
I copied and pasted, but
Yes,
yeah,
yes.
predicted, true at the end,
Yes.
would that be three predicted and then a true?
Yes.
Okay, gotcha.
Okay. Now here we
That's
go.
That's
what
how you read it.
Gotcha.
Do you know what is stratify? Okay. Can you remind me what this stratify function is doing?
Yeah, Stratify is going to give you like rows out of that, but you don't have to use it if you don't want to.
I
It just
forgot to
picks
use
up-
it, forgot to type it, and I got different results. I got
Yeah,
one.
exactly.
I get the accuracy 100%. So that is
Overtraining. Yeah. So
Overtraining.
basically, yeah, it's overfitting. Stratify picks it up at random. You're going to otherwise train on the consecutive values.
good.
Oh, okay. But random is seems
Random
to
is
be
good.
better. Yeah.
Random is good. I keep hearing the word overfitting, and this is a practical
I
demonstration.
hadn't understood about this before this semester. This semester I understood what overfitting means. It
Overfitting.
means the model being too accurate that if there is any variation in the actual data set that comes in the future, then it won't be able to correctly predict it. And it will give me as
Overfitting is the model is trying to perfectly presenting the data set in which it applied learning. So it will give you very accurate results, but
because
there is
Everybody good till here? After that, we are going to go and see what is a confusion matrix. Okay. We saw this metric when we were in our yeah, and also in the slides. But are we good till here? Yes, everybody has the confusion matrix. Then let's visualize. The skill for you to learn is when you look at a new function, right? You need to understand what all attributes are passed into it. And the best way to do that is Google the function name and look at its official source on the Python website. I'll show you how. function does, right? So I Google search this, right? Now I see there is an official documentation for scikit-learn which shows me what is plot tree. I did not know what is plot tree here. Okay, I did not know how to use it. What I did was I simply did this plot tree Python, and I saw there is an official documentation for plot tree on scikit-learn. That's what we are using, right? So when I click it, it shows me how the function is written. The decision tree should be passed here. What should be the max step, the feature names, everything that you can pass to it. Explain parameters for all of those parameters, explanation. What does it return and how to use it. Okay, how to use it in examples. So it's important to be able to find the documentation related to that function so that you can look at its parameters and how to use it. Okay, if this does not provide a good example, like this does not, this is what we can do, and it shows you how to use it. Okay. But I did try to use comments, so you understand what parameter is doing what. Good. Are you okay?
Can I get a break? Can we have a break? Short one?
Yeah. As soon as you are done with the visualization, we are pretty much done.
Can you know how to read in terms of the colors? What does it mean? Just I think it's easy, but
Yeah.
I am a little bit. It's like very colorful and bright.
So it's the attribute that's splitting on it, okay?
Okay.
That's what.
And the purple means is it? So green is good. Purple is.
No, it's no such thing. It's just color coded. Honestly, this visualization I have never understood much better than what we do by hand. I have a habit of adding a small summary also. So you should also have a habit of adding small summaries to whatever you code.
Okay.
Good? Done? Till here?
Yes.
Lot show?
I just want to,
Uh-huh.
I accidentally did
No, you're right.
one thing.
You can take a small break.